In this video we're going to be looking at a question from the Maths Leaving Cert paper 2 from 2022. You'll find some timestamps below the video if you want to skip to a specific question, and also if you want to go to a different question that I'm covering in this video, check out the playlist that you should find a link for in the description below. And this is question 5. This question is going to be all about geometry and trigonometry, and it's all going to revolve around triangles. Part A, well actually before we even get to part A, the question tells us about an equilateral triangle with a side of length 8. I've drawn that here. Now the first thing I like to do when they give me something, if there's anything easy I can do, I fill it in. And this is easy if you know what an equilateral triangle is. And unfortunately, there's not much in maths you need to memorize, but you do need to know what an equilateral triangle is. You do need to know what an isosceles triangle is. In this case, an equilateral triangle has equal sides. All sides are the same length. Also, all angles are the same length. And all the angles add up to 360. So that means all the angles must be 60. So I do that before I even look at the question. And then question A, part 1, actually asks me one of these. It tells me to write down the angle PQR, and that's just 60. Let me just talk about this for a moment. A lot of students don't know how to read this. This just says angle PQR. Let me draw what this means. Start at P, go to Q, and go to R. So that's what angle it's talking about. There's only one angle this could talk about. It's this angle here. So PQR talks about this angle in here. Now it doesn't matter in this question because they're all 60. But for future questions this may be important. Now for part 2 they ask us to show that the area of the triangle is 16 square root 3. Basically they're asking what's the area. So how do we find the area of a triangle? Well, most of you know the formula A is equal to a half the base by the perpendicular height. That's not going to be the best way to solve this, but it is the way I'm going to do now. I'll show you because most of you guys probably think of this way first. If you look in your formula book though, it will give you multiple formulas. It will give you this one, A is equal to this. It'll also give you a half AB sine C. It might have some different letters, I apologize. And then they give you another one, which I don't know offhand. Something has S and A's and B's and C's. We're not going to use that one, so I won't bother with it right now. There's different times you should use different ones. The last one has all the sides of a triangle, but none of the angles. So that can be useful. In this case, we do have all the sides, but we do have angles as well. This one is probably the easiest to use. It is when you have two sides and you have the angle in between them, and we do here. We have two sides and the angle in between. And this one's the famous one. It's really good if you do know the base and the perpendicular height. In this case, let's draw a picture again. We don't know what this height is. I am going to go ahead and solve it this way because it's what a lot of you probably tried to do when you attempted it. And it actually answers part 3 of this question. So we're in part 2. We're going to answer part 2 and 3 at the same time. And then afterwards I'll show you how to do the second part. This easier way. Okay, so half the base by the perpendicular height. The base is 8. The height, we don't know it. So we're going to have to find that out. How we do that, we know the hypotenuse here, or well, we know this side here is 8. So I'm going to break this up and turn it into a triangle that looks like this. With a right angle. This dotted line down, a right angle here. What's the length here? It's actually 4, because it's an equilateral triangle. If we cut the angle here, we cut the side here. This is 8. So to get the height here, we just need to use Pythagoras' theorem. So Pythagoras' theorem tells us that the sides, let's name it something. We'll name it x for now. Tells us the sides x squared plus 4 squared is equal to 8 squared. And we just have to solve this. And move the 4 squared over. We get is equal to 8 squared minus 4 squared. You can go ahead and change these into 64. Sorry, this should be squared. That should be 64, and this could be minus 16, or you don't have to do it. You could do that up here. X squared is equal to, let's see, 5848, and that means x is equal to the square root of 48. And if you go ahead and put that into your calculator, it will tell you that the square root of 48 is 4 multiplied by the square root of 3. Let me just double check that. 4 squared is 16, square root of 3 squared is 3, 3 times 16 is 48. That's great. So that's your perpendicular height. So if you want the area, it's just a half times the base, the whole base is 8, times the perpendicular height. Put all that into a calculator or do it yourself. 2 goes into 8 4 times. 4 times 4 is 16. 16 times the square root of 3, which is, yeah, that's what they wanted us to check. Let me quickly rub this out here and I'll show you how to use this formula. So if instead you had to realise this formula existed, and it is much easier to use, we could have simply said A is equal to a length times a length multiplied by the sine of the angle in between it. So we just pick any length, any two lengths to have an angle in between it. So A is equal to, it's a half, isn't it? A half times 8 times sine 60. Again, we put all that into a calculator, or we can do it ourselves. 8 times 8 is 64. Half of 64 is 32. And again, you either need a calculator for this, or you can look up your formula book. And your formula book will tell you that the sine of 60 degrees is square root of 3 over 2. 32 divided by 2 is 16 multiplied by square root of 3. You get the same answer. Again, you could have put this line in your calculator, and if you're good enough using your calculator, it should tell you this is the answer. Either way, that's the answer to part 2. And then part 3, I'll do quickly. It asks hence or otherwise. That means you may have already done it before. Hence or otherwise. They often say that. Find the perpendicular height of the triangle. That would be x here. So yeah, and give your answer in the form of a number multiplied by square root of a number. So we've already done that. That would be answer to part 3. If you did do this in part 2, you wouldn't have to do it again. You could just write in done above, as seen above, something like that. Write the answer again, and just the examiner would know to look above. Okay, on to part B. Part B, they give us this triangle here, 12 on the base, 30 the hypotenuse. It's a right angle triangle. And again, they ask us to find the perpendicular height. And that made me realise part A. I just show you quickly something from part A. The equilateral triangle. They wanted to find the perpendicular height here. There was an easier way now that I think about it, because I don't think they'd want us to use Pythagoras theorem twice in a question. 8 and 4. You could have just gone ahead and used trigonometry here. 60, 4 and 8. We could go ahead and use one of our rules, sine, cosine and tan. How I remember them, everyone has their own little way, is oh hell, another hour of algebra. So we have the adjacent and the hypotenuse in this case. Oh sorry, we're looking for the opposite, so we better need that. We don't need both of these. Pick whichever one you want. They didn't give us this one, so I'll assume most people have this one. We have the hypotenuse, we want the opposite, and we have the angle. So we have sine here. Would go ahead and do it. Sine of 60 is equal to the opposite, which is x, divided by 8. Rearrange that, we get 8 multiplied by sine of 60 is equal to x. Go ahead and put that into a calculator, and we get the and we get the previous answer, which would be sine 60 was square root 3 divided by 2, so it's 4 square root 3, which again is what they wanted. That's the interesting thing about these geometry and trigonometry questions around triangles. There's very often many ways to do it, 3 or 4 different ways to do it. So apologies, I probably showed you a longer way. That's probably the best way. Anyway, part B is going to be just like the Pythagoras question we did before, so we can do it quite quickly. We're looking for this side here, so let's put a letter there. Any letter you want, we just use x. And we use Pythagoras theorem, which says x squared plus 12 squared is equal to 30 squared. Rearrange this like we did before. 30 squared minus 12 squared. Go ahead and use a calculator to help you out with that. What have I got in my notes? That would be x squared is equal to 756. Yeah, 56. So that would mean x is equal to the square root of 756, and that comes out as a decimal place, and they ask you to find the answer correct to one decimal. So it comes out on your calculator 27 point, I don't have it from memory, I did this question yesterday, I think it's something like 49 something something. So one decimal place, this 4, is it closer to a 4 or a 5, or a better way to think of it, is it closer to 40 or 50? And it's closer to 50, so we go ahead and put 27.5, and that's the answer for part B. Yeah, apologies, probably a bit of a mess answering that, but that's because there's just multiple ways to answer these questions. Hopefully I showed you a few of them. Any questions, ask me below.